electrical system utilizes a TNC 2.0 microcontroller unit as well as a USB OTG cable for serial communications to the phone. It also has a dual H-bridge motor controller as well as a 6-volt switching regulator, power distribution board, and boost converter for the solenoid kicker.
The vision system of the robot is based on a standard Android phone, equipped with a wide-angle lens running an OpenCV-based application. The application detects objects by looking for their specific colors and then passes the locations of those objects to the navigation system.
The robot has a differential drive system powered by the 1300 mAh battery. It has a clear window for camera view and multi-layered component housing. All the housing components are laser cut and 3D printed.
The nav system localizes the robot's position with dead reckoning and using wheel speed feedback to keep track of the position. It takes vision information and decides on a target position using planned navigation methods and sets wheel speeds using a proportional controller to move the robot to the desired location.
All the design prototypes was done using a CAD modeling software SolidWorks. Rapid prototyping such as laser cutting and 3D printing was used to produce parts. This is the first prototype that was proposed to commence testing. The main purpose of the design was to figure out the best position for the phone in the robot. This diagram briefly explains the position of the component in the robot. Once the phone mount angle was finalized, the set position for all the component was worked out.
The electrical system is powered by an 11.1 volt 1300 mAh battery, which is distributed to the dual H-bridge motor driver through the 6-volt regulator and also to the solenoid through the boost converter, which takes the 11 volts and boosts it to 30 volts. The motor controller has 2 motor outputs as well as 4 PWM inputs for forward and reverse for each motor.
The robot's vision system consists of a Samsung Galaxy S2 smartphone with a wide-angle lens attached to it. This smartphone is a custom Android application made using the OpenCV3 libraries. This application takes an image frame from the camera in RGBA format, converts it to HSV color space, thresholds that image for the colors of the objects we are looking for, and then uses the bit mask generated to find the contours of the objects. The bounding boxes are then placed around these objects and used as a guide to estimate their apparent size, which is then used to calculate the distance and the angle to them. This information is then passed to the navigation system.
There are 5 main software modules in the design of this robot. These are the vision, localization, navigation, control, and communication modules. Additionally, the embedded software includes control, sensing, and communications modules. The vision module gathers data from all the objects in the field that it can see and updates all the other modules once per camera frame. Localization is done by a dead reckoning, taking the starting position of the robot as the origin and 0 angle. The robot first maps its surroundings by adding the bearings relative to the robot of any objects it sees to the robot's position. The navigator has search, acquire, and score states that it will dynamically switch between. The navigator decides on a desired position and the controller sets motor speeds to move the robot towards this desired position. The microcontroller sets the motor speeds to those desired from the controller and feeds back the actual motor speeds to the localizer for dead reckoning.